Hello, how are you guys? Yes, I know you expect me to standing in front of the class and see me physically. However, basically I'm still in Hong Kong. I won't be able to take the first few classes for the chemistry this year. So however, what I plan to do, I'm trying to make a series of videos for you guys to look at, and also try to explain to you what we are going to do in the next few classes. So let me explain how everything's work this time. So hopefully you know that you are 2018 year 11 chemistry. If you find yourselves not at the right room at the right time, you can move away. For those, hopefully there's no new students as well. So for those who's new to the Alia, my name is Joe. Generally the science and maths teacher here, and I like to basically try to explain to you what we're doing this year. So for the first 2 weeks when I'm away, I'm going to make you guys 3 video clips, and this one is the very first one. And these video clips include what you need to do. For example, in each video clip, you will find there would be 10 guided questions for you to finish. And then after you've done the 10 guided questions, then I'll give you some, I have given you the workbook. Hopefully you will receive that from the office. In this workbook is 17 pages altogether. For each video clip, hopefully you would be having enough information to finish about 3 to 4 pages. So it's more like a self-guided learning for the first 2 weeks, and I know it's not ideal, but this is the best that I can do while I'm away. What we do now, try to explain to you what we kind of like do the assessment, because everything needs to be assessed in VCE classes. So in terms of your work, this week is easy. This is your very first class of the year, and you will have next week for the school chem. So I won't be too harsh on you this time. They will be giving you a little revision today and give you some simple questions. All you need to do is try to attempt those questions and bring it back, or next class. So next class, none of you will need to turn up to the official timetable, but you are required to get online to watch the second video when you are back from the school camp. It will be online. What you do, you can either go to check your Dropbox or go into the office and ask for the link. So those who were here last year, you should know this pretty well. Dropbox. I love Dropbox, so everything that I'll do, I'll put into Dropbox. And in the Dropbox, there will be a folder for you. And the folder, so what we do, the folder there in my Dropbox, I've got the whole thing here in my Dropbox. You won't see everything in my Dropbox, but I will share one folder with you, which is this one, 2018 year 11 chemistry. This file, this basically folder, when I click inside, when I click in there, it has everything that I've done so far inside. I have the updated periodic table inside. I also have the year 11 study on chemistry test book. This is very important test book because I'm going to use it for the rest of the year. Then week 1, what does that mean is in week 1 I expect you to finish things in there. You will have the digital version for the workbook. If you're keen to do digital everything, you don't need to have the hard copy, and you just fill your answer with the just type your answer in your workbook and send it back to me. And then you'll see there's a video 1, 10 guided questions file. This one, you have all the questions you need to answer in this video. So please print them out, write the answer down, or just answer them in the file. Type it up and send it back to me. So what do you require to do is to make sure that you have your Dropbox account, you have created your Dropbox account, and check regularly. So at least check it once a day. But what happened is, whenever I try to upload my folder in it, there should be a notification in the Dropbox icon there. So if you see there's a little things to pop up saying that a file being uploaded, that probably would be me, and you need to go and check it out in the Dropbox. I won't be able to upload the whole video on the Dropbox. So what I would do, I have a file. Inside the file, you'll find the links, and this link would link to the next video clip. As well as inside there will be 10 guided questions with the link. You answer them, send it back to me. And how do you send it back to me, and when do you do it? The first thing you need to do is to choose whether you want to do it like type it up or write it down. If you choose to write it down, you have to either take a picture with your phones and send it to me, or you can do the scan. If you scan it just with the scanner, with the photocopier outside at the foyer, you'll be fine. For those who still don't have my email address, please copy this down, and you are supposed to hand this one in to me every Friday. So for example, if you come, don't count today, don't count this week, because it's basically not a teaching week, but next week would be your school camp. So the next Friday, you are required to finish the 10 guided questions I gave you today, and take a picture, scan it, and send it to me. I won't be angry if you didn't do it, but I will mark you late to hand in your work. It's all about assessment tasks, especially when I'm not here. I don't know how much work you have done, and I have to keep a record of your work, and to show that, okay, I know the students, and then when I give the grade to you, it will be accurate, not something that I make up. So even though sometimes I make up your grade, but I do need to have the evidence to guess where you are. So hopefully it's all clear for the first few weeks, and the most important thing for you is to get the Dropbox. Once you've got the Dropbox, you need to make sure that you're able to send your work to me with the emails here. So make sure that you copy my email address, and we will communicate with this for the rest of the year. Right? Hope everything makes sense to you right now. Then what I'll do next, the next thing that I'd like to do is briefly explain to you what the Unit 1 is all about. In Unit 1, generally I divided that into two main topics. The first topic is the fundamental chemistry concept. In this particular area of study 1, we have a few areas to focus on. The major things, everyone, when they try to first study chemistry, they will tell you, okay, it's all about periodic tables. Yes, they are right. It's all about periodic tables. Chemistry is about elements, about how they interact, and we have find a lot of elements and they all list in the periodic tables. But be honest, I never remember them because it's so easy to grab. I only remember the first 20 or 25 up to 30. You will require to finish to remember up to 20 by the end of this term. The first is periodic tables, then the second one is all about atoms. There's a lot of theories been kind of developed so far, and we need to look at the history, and we need to look at how scientists come up the ideas of atoms. No one has ever seen them, and they do behave very interesting, the way that they behave, and we need to study them. The other one that is all about the calculations. Okay, if you're really bad at math, I can help you out. Chemistry has a lot of calculation involved. Yeah, just like when you're cooking. You just saying, I don't bother. You put 10 eggs and you're supposed to make a cake. Then you're saying that the recipe said that it's 2 eggs, and you're so bad at math that you put 10 in it. I can't help. Basically, the calculation part involve lots of units and lots of conversion between them. One of the major units that you will learn about is called mole. And mole is a kind of interesting concept. You will see how frustrated you will get frustrated for a while, but once you get the hang of it, it's easy. It's really easy calculations. If you're able to do 1/3 plus a quarter, you can do mole. Right. The second area of the unit 1 would be all about chemical bonding. In chemical bonding, we need to discuss there's something called ions in the world, and there's something non-ion as well. The things that is ion bear charge, the thing that's not ion doesn't bear charge. The way that they interact with one another and the bonding, how do they stuck with one another, they behave different from it. They do different way, and we need to learn their way. Hopefully you don't feel strange, or you will be kind of familiar with the terms ionic. Another terms covalent and metallic. So all of those type of bonding would be involved. Would be in this particular syllabus in year 11, and we need to look into it in details. Don't waste any more time. I need to go directly into the course. So let's have a look at the course. Very first thing, I want you to tell me that I want to ask you a question to begin with. How do we measure the size of an atom? If I'm teaching you face to face, I expect that you would just raise up your hands and try to say, I know the answers, and try to give me the ideas. But I can't interact with you, so it would be a boring class. I will try my best to explain how scientists come up with ideas of the size of an atom. One thing that you need to know is atom has no boundaries. Atoms has no definite boundary. What does that mean is, we all know that in every single atoms we have a nucleus. A nucleus sits at the center of an atom, and then we find there's funny things around nucleus. We call them electrons, and don't ask me why we call them electrons. Maybe electrons, electricity, I don't care, but they bear charge. They bear negative charge. All the nucleus has kind of a positively charge in there, and electrons has a negative charge. when you try to measure the size of an atom, we are looking at the furthest. Let's say this is the furthest of the electrons. We have this as the furthest. How do you spell furthest? Yeah, maybe like this. This is the far, far away electrons. And we would try to measure the distance between the nucleus and that electrons. Think about that. I am a fair kind of a magician most of the time. Everyone is a magician. We make energies. If you try to pump the energies in there, let's say energies going into it, and we have all the, when the right energies is placed and the electrons absorb those energies, what the electrons do? The electron move further away. So if you keep getting more energies into it and then more energy into it, the electron basically go further and further away from the nucleus. So what would be the size of an atom? Does it mean that the atoms are basically getting bigger and bigger and bigger? Yes, you're right. The atom is getting bigger and bigger. If you are trying to count the electrons moving away from the nucleus. And everyone, basically scientists, agree with that. Atoms has no definite boundary or definite size. Then we have all the measurement. Well, how come do we say that hydrogen is the smallest atom at all, and then the others is a little bit bigger? Yes, we found basically a very, very funny way to do it. We call this atomic radius. So from now on, when people saying that, okay, I know the smallest atom of the entire universe is hydrogen, you can kind of correct them. We don't really know the size of the hydrogen atoms, but we do know the atomic radius of the hydrogens. Then based on the atomic radius, hydrogen has the smallest size. Then you basically telling people you know some chemistry and you do study year 11 chem. So what would be the alternative way? Because the electrons and the nucleus would not be the way that easy to measure, because they varies all the time based on the energy interaction between them. The way that we do is to find two hydrogen atoms sit next to each other. If we try to put two hydrogen atoms sit next to each other, there would be a gap from the center of the first one to the center of the second one. And this one would be able to measure. For example, a hydrogen gas, you can measure them. Hydrogen gas, two hydrogen atoms sit next to each other. There would be a size here, and the radius would be here. Half of the circle is a radius. If you try to compare this with, let's say, chlorine gas, because the valence electrons most of the times getting a bit further away from the nucleus, and when those two interact with one another and form bonding, they push the nucleus a bit further from each other. If they push the nucleus a bit further from each other, you will find that the nucleus, or the radius of the chlorine would be way bigger. Based on the atomic radius, we try to determine the size of an atom. And by the information that I've got, hydrogen gas has an atomic radius of 37 pm. What is pm? what P stands for. P is called pico. P stands for P-I-C-O, a pico. Pico is a mathematic term, means 10 to the negative 12, a pico. A 37 picometers would be the size of a hydrogen atoms. While when you try to look at chlorine gas has about 199, a picometer. Right? So yes, so I think that is a very interesting point to begin the chemistry that we talk about. We always talk about chemistry. We always talk about atoms, and we think we know about what is the smallest size of the atom, what is the biggest size of an atom. But yeah, no one. I don't think like you have ever seen. We can only estimate the size of atoms. We would never able to say the size of an atom is blah blah blah. It can't be, because an atom has no definite boundaries. As electrons keep moving, you can pushing closer to it or move it away. And this one also basically all chemistry is involved with electrons. And knowing the electrons moving is pretty crucial for us to understand chemistry. Okay, so hopefully you are happy with the atomic size so far. Then, if you say I'm able to say it's the atom is big and the other atom is small, and how about generally if people are asking you about what would be the atomic structure of an atom, and what would you say if that is the situation, so atomic structure? So no one have seen an atoms, or what do they look like, and even you try to use the most powerful microscope and you won't be able to see any internal structure. So if you try to see, like you do an X-ray, you can have the X-ray film and you can see the bones inside me. But you try to do X-ray and put it under the super microscope for the atoms, you won't see anything. You won't see at all. So how scientists or chemists start to study atoms? We got very frustrated because we know it's there, but we can't see them. And throughout the time, it comes into there would be a lot of people try to explain what is an atom. The very first guy that tried to explain is called Dalton. So in your guided questions, it would be a few things that I'd like you to illustrate. What is the Dalton models? Illustrate what is the next model. Illustrate what is the other one. I'd like you to basically read the book. There's a particular page in the book telling you the history, the development of the atomic structure over the years. The first guy is called Dalton, and this guy is pretty much say that it's a rock. So everything is made up of a tiny solid particle. And this solid particle is solid particle. You can't break it, and it's unbreakable. So we call them atoms. So, and Dalton gives us the definition of atom is called unbreakable. Unbreakable, but now we know that atom is not the smallest particle at all. We have subatomic particle, we have protons, neutrons, electrons, and if you try to study a bit further down, neutrons can be like different types and blah blah blah. There's whole heaps of areas that we can explore nowadays. But back in the old day, the very first guy that suggested, okay, everything made up of solid particle. That's the smallest. You can't break it. That's it. Full stop. And Dalton suggests atoms as a concept. Then, if you try to go to look at your book and further down, it comes to another model, which is have a very funny name. I like it. The name is called plum pudding. A plum pudding has a step forward of a solid particle, because a solid particle doesn't explain a lot of things. So it doesn't explain like how about like different charges can find inside, like in the atoms, stuff like that. And the plum puddings, hopefully you understand this is a pudding in here. And the plum puddings has lots of tiny plum ingredients inside, and have a kind of a jelly, makes a jelly things in there. That plum puddings explain to you this is more like atomic structure. It's more like a fluid, but it's still like kind of able to mobile. But inside the pudding, those we can't say there's electrons there, because the plum pudding doesn't suggest electrons. Then they will say, okay, there will be a plum pudding, there's a kind of a liquid jelly stuff, and lots of like little particles is floating inside. Not floating, it's kind of like stuck in there. But it's still able to move a little bit. It's like jelly pudding. But very quickly, this guy that's not really convincing, and come up into this guy called Rutherford. Rutherford has a much better understanding of atoms, because he has done a very, very famous experiment. And this experiment required a very precious metals, which is gold. This guy tried to do one thing, is try to hit the gold with a hammer and make it into as thin as possible, a gold leaf. Even the gold paper, even thinner than the paper, because gold is very malleable, and you keep banging and banging and banging into it, they won't break. But you can see, like that so thin piece of gold, then you would expect in this piece of gold, maybe you can see those gold atoms. You have maybe 20 or a few hundred layers of gold particles or gold atoms in it, and this guy tried to shoot a radio wave into it. So this radio wave, which is called gamma, try to shoot a gamma wave ray into the gold piece. So if there's a Dalton or plum pudding situations, everything you expect would be bounced back straight away. But in reality, he discovered if you try to shoot a ray into it, most of the time it passes through the gold leaf. The other angle, you keep going, find the other angle, find the other angle, find. Occasionally, when you hit it, it bounces back. And he do a little collection of calculations. Then he find out that's easy to explain, because in between inside the atoms is not solid. It has lots of gap, empty space. And that is a huge breakthrough, because it helps us to understand one particular concept, is it has nucleus. And the nucleus contains most of the mass. So if it doesn't contain most of the mass, it won't bounce back. And most of the ray pass through because there's a big gap in between each of the nucleus. That is very obvious and from the experiment, and everyone agrees with his find out. And based on this, find out Bohr models come up with it. Bohr's models would be the one that with the most basically we are familiar, the most familiar model for lower grade. What does it tell us is, instead of just saying nucleus consists most of the mass and the gap in between the nucleus is telling us we have the nucleus, but at the same time electrons are running outside in the orbit. So in a regular orbit, electrons are surrounding or circulating the nucleus. That is what Bohr suggests. And Bohr suggests one more thing is, so let's say there would be electrons circulating. And the other thing is, electrons are allowed to get excited, then relax. When electrons get excited, means that it moves from the lower to the higher. When you have electrons move from the higher one, go back to the original, we call them shell, the original orbit, then we call them relax. So by moving up and down that way, it releases different type of light, and that is been proved by flame test. So if you have done the flame test before, or just search flame test online, then will be fine. You can see that flame test. Then the people will tell you if you burn aluminiums or you try to burn aluminium salt or copper salt in a fire, the flame will change color. So when it's a green one, it's a copper ions in it and blah blah blah. So that is the flame test, and the ideas behind, or the concept behind the flame test would be the electrons are allowed to move up or down. So when they move up and down, this motion makes the colors appear. So I know it's really long. The very last one there would be QM model. What's QM stand for? Q stand for quantum. Hopefully I spelled it right. Q-U-A-N-T-U-M. M stand for mechanical. So we have the quantum mechanical model, which is basically try to give you one more concept, is atom is not matter. Atom is not just matter. Atoms can be energies. So what is energies? What is atoms? And then you can make atoms into energies, make energy into atoms. So what theory is behind that? Which is energies equals to mc squared. Change energies into mass, and then the mass into energies. So when you try to look at these important theories behind that, atoms behave in both ways. Atoms behave like matter. So when you knock the glass, you feel it. You feel there's a physical existing there. But when you zoom in there, atoms behave like energy as well. When you behave like energies, look at the wave. It has a particular wave form to like the motions of it, and they do interfere with one another. They do try to behave like lots of like wave phenomena. So when you try to look at that QM model, push this all the way into next level, which is all physics. not chemistry at all. I don't really care about this a lot because it's not about chemistry, it's about physics. So we will touch a little bit on, but we won't describe it in details for those. Right, yes, this is basically a very, very brief idea, history, development history of atomic theory. I'd like you to go back to the book and have a go.
Papa, 你有冇見媽咪個 bag 啊？
Okay, next one. Yeah, my kid just come in. I have to pause the video and then yeah, try to do it again. So what I'll do next, this is the last 10 minutes. In the last 10 minutes, I'll need you to understand the two terms: atoms and isotopes. In terms of atoms and isotopes, you know what atom is. Atoms basically is a not mixture. An atom is a combined protons and neutrons. Neutrons. N-E-U-T-R-O-N, neutrons. A combined protons and neutrons act as a nucleus with electrons running around the nucleus. So when you try to look at this, is the kind of definition of an atoms, and we can say each atoms, they different from each other based on the number of protons. So what does that mean? Why do I just focus on the protons? It's very easy to understand that protons bear positive charge. We say it's a positive one. And protons is a heavy particles. So we also call them, it has 1 unit of mass. Right? If you have 2 protons, you have 2 mass. If you have 2 protons, you have 2 positive. So the positive and the mass contribute by protons. If you try to understand the other 2, neutrons, it has no charge. It only bear 1 mass. So they're roughly the same, like the weight in terms of their mass, they're roughly the same with one another, protons and neutrons. And people suggesting neutrons is slightly heavier than protons. I didn't study details enough to tell you the difference. But like, yeah, if you know that the mass between them would be roughly 1 to 1, they're fine. Then what would be electrons? Electrons, in terms of charge, basically be able to it bear -1, it can show out the charge of the protons. But in terms of mass, it's 1,800 times less. So it's 1 out of 1,800. You can have exactly numbers in your book. Try to go through your book and have a look at the those properties: protons properties, neutrons properties, and electrons properties. If you try to look at that, protons basically kind of, I will say, has more severe than the other 2 because it has charge and mass, while neutron only has mass and electrons only has charge. To encounter the one that has both of the character. Then, because of that, if you just try to look at protons, it gives you something called atomic number. If you have 1 protons, 1p, atomic numbers equals to 1. If you have 3 protons, your atomic number equals to 3. Check your periodic tables. In your periodic tables, it lists put the elements next to each other based on the atomic numbers. What is the elements that has atomic number 1, which is hydrogen? And what is the elements that has the atomic number 3, which is lithium? And you can keep saying that, so what would be number 20? If the one that with 20 protons has the name, like the atomic number would be 20, then it has to be calcium. And the name or the symbol is determined by the atomic number, while the atomic numbers is equals to the number of protons. So therefore, to understand, to know, to read, to be able to read what is atoms or to explain what is atoms, we first need to know the number of protons, right? When you have the number of protons, then we basically are, that's the most important thing. Then we try to ignore the other two? Is not, because when you have protons plus neutrons, because both of them has mass, it contribute a number, we call them mass number. Mass number stands for the number from the nucleus. So let's say if we have 1 protons with 2 neutrons, your mass number would be 3. How do you write this as a symbol? Protons 1. We know that is hydrogen because it has atomic number 1 in there. So hydrogen would be H as a symbol. And H always come with 1 at the corner, bottom corner of the left hand side. The top corner is used to put the mass number. The mass number is always written at the right top of the left top corner. And you always hear a term called carbon 12 and carbon 13. And what does that mean? Carbon 12, carbon 13. The difference between carbon 12 and carbon 13 is both of them has 6 protons. But if the mass number is 12, 6 plus a number equals to 12 needs to be 6. You will find that carbon 12 contains 6 protons and 6 neutrons, while carbon 13 has 6 protons and, hopefully you will answer, 7 neutrons. And the one that has the same number of protons but different mass number, we call them isotopes, right? Hopefully you understand them all good. And let's try to have a look at your guided question 1, and to finish off today. I think for the first class it should be enough. 2018 11 in week 1, and you will have video 1 10 guide questions. If you open this online, you'll see the very first question. You need to fill in the table below about the relative mass and the charge of the 3 subatomic particles. So relative mass would be electrons, protons, neutrons. I kind of like make it a bit change the way that I explain. So try to fill that in. The question 2 would be the sum of protons and the neutron is called mass number. Try to explain to me what is isotopes and try to tell me what is the charge of all the pure elements. All pure elements need to have the same number of protons and the same number of electrons. And I've done a briefly describe the method for measuring the size of an atom. Tell me how do we get the atomic radius, or go and do some research about atomic radius. Illustrate Dalton model, try to draw a picture and put a little note next to it. Plum puddings, Rutherfords, Bohr models as well. Yeah, I need to give you a bit more lines to fill this in. And then the very last one, yep, fill in on page 14, you will be able to find out how do you calculate the maximum numbers of each energy level. So I think I need to finish this up of these questions. So what is maximum number of electrons capacity? Electron capacity refers to the orbits. So let's say if we have a nucleus, carbon. Carbon is number 6 atomic numbers. It has 6 protons. If we just consider carbon 12, we have 6 protons and 6 neutrons inside the nucleus. And in the nucleus, they always stuck with one another. However, all the electrons would circulating around them. The very first one there, we call them number 1. We use little n to refer n equals to 1, means the first shell. Shell means the orbit. And the first shell means it's the closest one to the nucleus. Then when n equals to 2, which is the second shell, the one that next to the number 1. So when you have n equals to 1, n equals to 2, scientists, funny, they come up with a formula which is called 2n square. And this 2n square is what we call the maximum electrons capacity of each shell. N, as I say, it means the first shell or the second shell. If we do a simple calculations, when n equals to 1, 2 times 1 square equals to 2 times 1. The maximum for the very first shell is 2 electrons. When n equals to 2, 2 times 2 square equals to 2 times 4. The second one is 8 electrons. So, and so on and so on. When n equals to 3, you can do your calculations. Once you've done the calculations, go back to this. There, 1, 2, 3, 4. There's a particular symbol. You don't need to remember it, but I'd like you to give it a go to find it. It's in the book, page 14. And try to do the maximum number of electrons, the maximum, the capacity for each shell. Then, yes, it means that it would be the end of the first video. I will see you kind of next week when you're back from the camp. And yeah, hope you enjoy the video, and I'm sure you will send me some work on Friday. Okay, bye bye.